Hello and welcome to the third video in the virus community build. Now last time we finished off putting the mini drac together, which was the clear winner from the votes. Again, don't be disheartened if you didn't see the AR wing actually being built. I'll put a link down below to the Ardu Pilot F405 AR wing build where I actually made one of those. The AR wing is very easy to put together, so it's probably a good one to try something else like the mini drac, which I haven't done yet on the channel because there is an awful lot of steps. This time it's about the flight controller. Now this is a bit of an interesting one because there is a pretty even split between the kind of radio system that you guys want to see and also the flight controllers that you want me to give it a go with. Now this just happens to be the Maytech F765 wing. They have such fab names. And I've also got the Maytech F405 wing here as well. Now I was asking which one you wanted to see, but it is so close. So when I look at it right now, the 765 is slightly ahead. If I look at it tomorrow, it's probably going to be about the same again. Because there is such an interest in both of them, I'm actually going to set up iNav on both. We're only going to use one in the model, and we'll use the one that makes most sense, and we can talk about that as well, which again, I think would be a useful comparison between the two flight controllers. So in this video, the plan is going to be, first of all, I'm going to flash the F405 with iNav, show you how to set that up with a standard radio, so S-Bus input, a GPS, with a video transmitter and a camera, show you how to do all that stuff. Nothing new in there at all, really. We've done iNav on a number of things. The Brain FPV Brain Dart series with iNav, the setup is identical. So the hardware, it doesn't actually matter what the hardware is. Once you've got iNav on it, then you just kind of follow the process. But once I've done the F405, then we'll go on to talk about this thing, the F765 wing. And talk about, there's a couple of extra things you need to be aware of. This one supports dual cameras. It also has more options for different voltages for different things. So I've set this one up, soldered all the pins on. That's a good half an hour's job with a fine tip soldering iron, and we'll go through and we'll show all that stuff. Again, we'll flash iNav to it. The setup in iNav will be identical as the S405, the F405 even, as I've just explained, but I'll show you how to do the camera switching. And then what we're going to do is then go back to the F405 and then plug in a Crossfire system, show you the two options for that. With Crossfire, you can either connect it via S-Bus, just select one of the outputs in Crossfire as S-Bus and plug it into your S-Bus input. Bingo, you're done. Or you can use CRSF, and I've done that in a number of other builds. CRSF connects to a UART and gives you bidirectional control of the flight controller and everything else. It's some quite cool stuff. It's also faster than S-Bus as well. So I'll show those two things. And finally at the end, I'm going to connect up one of these flight controllers to the DJI HD digital system and show you how that works. Because out the back of the airside unit, there's two connections. The first one is S-Bus. So guess what? You plug that into the S-Bus and away you go. And the second one are two pins that's used to download the telemetry. Now, right now, the on-screen display within the DJI HD goggles will work with iNav, and that's because iNav emulates Betaflight telemetry. If you don't understand all this stuff, don't worry about it. I'll put a link here so you can go and have a look at that particular video. But the bottom line is you can get your telemetry into the airside unit that will populate the on-screen display in your goggles. You can plug S-Bus into the S-Bus input on the flight controller, and you're set. So time codes below for all of these different sections because I'm going to cover a lot in here. It's probably going to be slightly longer than I normally would do, but because there is such varied interest and because so many people want Crossfire, so many people want FrSky, loads of you want the 765, loads of you want the 405, you know what, I'll just do everything and then we'll choose one at the end and then I'll put that in the plane in the next video. So to the bench, let's flash the F405 with iNav. So it's worthwhile us taking a moment just to think about the different pieces that's going to have to be plugged into this F405 wing once it is flashed. I'd recommend when you're ever doing this, just connect a temporary lead to be able to power it, because things like the GPS aren't powered from the USB connector. Now, make sure that all the pins are installed, because we're going to have to, once we've flashed it, put the receiver in. Any S-Bus receiver is going to work fine. An S-Bus input, whether it's from Crossfire, DJI, whatever, it doesn't matter. Then we've got the GPS, only 4 connections of the 6 that are typically available, a ground, a 5 volts and a transmitter receive, so that'll need plugging in when we've got it flashed as well. The other 2 wires are actually for the external compass. We don't need that for a flying wing. I'll put a link below for my video about why that's the case. Then we need the Analogue FPV stuff, good old little micro eagle, I think this is, from Runcam. And there's only 3 wires on this. We need power, ground, and the video out. Make sure that the camera you're using is going to support the voltage from the flight controller. So most modern cameras have a pretty wide voltage input. And then we're going to need a video transmitter. I'm using the Atlatl from Holybro, and that has 4 wires, a power, ground, video in, and also a control wire for changing power frequencies and bands. But before we get into any of that stuff, and before we connect anything up, I would recommend let's flash it and make sure it's happy. So here it is, all ready to go, nothing else plugged in. I'd recommend always doing it this way, and then if there's a problem, you know that it's not one of the peripherals. So we're going to plug it in, wait for the tone on the computer, and now we can jump into iNav and start setting everything up. So we're going to go into firmware flasher, and we're going to choose the board type that we would like. Now actually there's quite a few Matek F405s here, and if you're ever confused about what target you should be flashing onto the board, the trick is to connect to the board, even if you're, make sure we're on the right COM port, that'll work. And this will work even if you're plugging a board flash with Betaflight into iNav or vice versa. Then the command line, type in version, and it will show you the target that you need to pick. So we want 405 SE. Perfect. So let's disconnect, back into firmware flasher, choose the board, M on the keyboard will shortcut me to Matek. So Matek 405 SE, go for the latest version, which as I'm recording this is actually the one that's on it, but you know what, let's go and flash it anyway. So now that's all set, we'll leave all the defaults, go down to the bottom and click on upload firmware. It'll upload the firmware from the internet, and we click on go. Now this is working straight away. Occasionally when you do this, at the top right hand corner you see where it says DFU, where it was talking about a COM port before. DFU is kind of the bootloader mode that the flight controller needs to be in order to accept this update. If you do this and it says fail to open port or fail to communicate with board or something like that, and this isn't happening, then you're going to need to download and use something like Zadig. The links to the Zadig stuff is actually on the first page before you connect to the flight controller in iNav, and I have a video on how you use that to replace it. Other tools are available. If you're careful with Zadig, you're just replacing the STM32 bootloader, and then this would work. Again, I'll put a link to my video in the description. So first connection, we're gonna have to click on airplane, and it's gonna reboot. Now it's all on there, we're just going to follow the basic setup. Again, this is identical for pretty much any board you want to use. So let's move the board on the desk and make sure we can see it moving on the screen. Yes, it is. Then next thing we need to do then is we need to go into calibration and calibrate the accelerometer. So we're going to click calibrate accelerometer, hold it down the desk, click OK, and then we're going to start the process. We're going to click on it once, and it's going to read what level is, and we'll get that little picture filled in. Cool. And then we just move it through each side by side. There's no particular trick to this. Just try and keep it very still and try and keep it at the 90 degrees. Some sides of it are easier than others, and make sure you're just following along so you get all 6 sides. This one's a bit tricky with the power cable. And then we've also got upside down, which is also tricky with the USB power coming as well. So let's click that. And there we are, that's done. So that's the important part. And we're just going down all the tabs on the left-hand side. So next thing then, we need to apply the servo outputs that we particularly want. By default, there's nothing in here. The iNav flight controller doesn't know what we want. So we're gonna click on flying wing, but there's actually loads of different ones in here. They're all the defaults. So we're just gonna go on a standard flying wing with 2 servos. That'll work for the mini drac. Let's reboot that again, and it will come. Once it's rebooted, we can carry on. Go into outputs. Now the outputs are disabled by default. You can see that at the top. I would keep it like that until we get to the very end. You can change this with the kind of D-Shot protocol and all that stuff, but for planes, I'd leave it as standard. Go down into presets. Let's scroll down here because I think there is actually one for the mini drac. Let me just scroll down. Yes, there is. Cool. Click on that. Click OK. And then it's going to want to reboot it again. Here we go. Lots of rebooting for this bit, but this is all the fundamental building blocks of everything that we're going to do if we get later on. Now, so where were we? Oh yeah, so the ports. Now ports, we need to set it up as per the Matek manual. Now Matek are fantastic at this. On the page for the board, they not only show you exactly where we're going to plug all those physical things in, things like the camera, VTX and everything else, it also shows you how to configure the ports so that they all work. Now, although the Matek manual is showing a later version of iNav, I think it's 1.9, it will absolutely work for this 2.4 version that we're about to do. So what I'm going to do is I'm just going to copy what the ports are set for with both the TBS Smart Audio, with the GPS and everything else. We may have to come back and tweak all this, but hopefully if the Matek manual is good enough, which it usually is in my experience, we'll be ready to rock and roll. So with that all set, we'll carry on into configuration. So in here, there's not a lot we're going to change right now, to be honest. It's auto-detected the accelerometer, barometer, and gyro. We're going to need to turn on the GPS, and I would say the ground assistant type auto-detect. Now, because we've already set the GPS in the ports, when we reboot it next time, it's going to tell us. In fact, you know what, I'm going to turn on auto launch. I like auto launch permanently on because you can just kind of lob it and away it goes. So next time we go through the reboot, when it comes up, you'll notice that the GPS isn't there initially, but it will try and talk to the GPS and configure it. And then once that eventually times out, it takes about 10 seconds, you'll see the GPS up here as a red symbol. And that's fine because at the moment, one, the GPS isn't plugged in, but also it isn't powered. So now we've got that, we'll make sure that failsafe is returned to home. PID tuning, I'm not worried about. Let's just make sure to save that. Oop, reboot again. On-screen display, we could play around with this because when we plug everything in a minute, as per the Matek manual, hopefully everything's going to burst into life. Just want to make sure there is going to be something on the screen so we can see that it's all working on that RunCam Eagle. So I would do that. We can change the font. It looks like by default it's loaded up the chunky font, which I don't like, but that's easy for us to change later on. Right, that's the basic setup done. Let's go back onto the desk and let's plug in the hardware and then we can finish off the setup. So now we can start actually plugging things in, and it's just a case of connecting all of the pieces up as per the diagram in the Matek manual. So the receiver goes there, the camera goes in those pins, don't worry, I'll do some close-ups in a minute. Then we connect up the video transmitter and the GPS. So this is the GPS going into ground, 5 volts T4 and R4. The one by the side of that that's going into the ground, 4.5 and S-bus is actually our S-bus receiver. Maybe you can see it a little bit clearer from that side. So that is going to be UART4 for the GPS, which we've already set up. And there we've got a much clearer view of how it all goes together for the camera, ground and 9 volts, and also the connections for the video transmitter, which is the video out, the ground and the 9 volts for that as well. So on this particular flight controller, both the camera and the video transmitter need to be happy running at 9 volts. That's slightly different on the F765, but I'll show you that in a minute. The only other wire we've got in there is going into T3. That is the smart audio connection for the video transmitter to allow us to change power levels, bands, frequencies, and all that goodness. So now we've got all the hardware together. One last quick check to make sure that we haven't got any shorts over the pins, and we definitely haven't, so that looks good. One final visual inspection to make sure that we haven't got anything wired incorrectly, and it absolutely matches the diagram from Maytech, and then we're ready to plug it in. So here we are on the bench, everything's set up. The receiver is bound to the radio. We have a radio, very simplistic radio setup done. We don't have any mixing or anything on the radio because iNav will take care of it. So we have the 4 main controls, and we also have a handful of other switches for arming, modes, and some extra bits too. Have this video screen, the FPV screen from my Fat Shark transformers, so we can actually see how it works. So let's plug it in for the first time. Oh, that looks promising, no smoke. And we can see out. It's saying that we've got an invalid font, but that looks great. It's looking out over the build desk. Everything has burst into life. That is fantastic. Okay, so a couple of things then we can finish off for this part of the build. So let me plug it back into the computer, jump back into iNav. Apologies for all the complaining from the radio. The radio and the receiver very close. So now in iNav, we can see a couple of things have changed. The big thing is that you can actually see at the top, the GPS has now gone blue. The GPS is powered, it's configured up, it's very, very happy. So if we go into the receiver tab, then we can move the controls. If I move the throttle, yeah, the mapping's wrong, that's fine. So we're going to go and change that into the bottom one, click OK. And then now the mapping should match how it is on my radio, which it does. Make sure the middle channel value is 1500, all the standard stuff for setup. And then the only other thing is in on-screen display, it was warning me about the fonts being incorrect. So we'll go down to Font Manager, pick the default font, and we'll just click Upload, and away it goes. And when it reboots at the end, we'll be able to see it, and it'll be working absolutely fine. So that's all the basic setup, relatively straightforward. There we go, just finish. It'll bounce now and restart with the new font. Let's just zoom in to make sure that bit, there we go. That is great. So next one then is, let me drag out the F765 and talk about some of the differences between how you'd have set up this and how you set up its bigger brother. Now the setup for the F765 wing flight controller in iNav terms is going to be exactly the same. However, hardware wise there are a couple of differences, so it's worthwhile me talking about those. As usual, this thing comes with none of the pins soldered, just like the 405 does, so be aware of that. If you order either of these, unless your vendor or reseller that's supplying it to you is very, very kind and will do the soldering for you, you're going to have to put aside a good 30-40 minutes just to make sure that everything is all soldered up. But the big headlines on this is an F7 based processor rather than F4 one in the F405 that we just set up. So it has a more powerful CPU. It has dual camera support, and I'll show you how to set that up in iNav in a second. It has one more UART, so it has 7 UARTs as opposed to 6. So loads and loads of places for you to install things. And also has one soft serial. Now the big difference here, of course, as you've probably spotted, is the top shield on the F405 is just a passive piece of technology. It just goes over the top to protect the board. In the F765, it's actually a voltage regulator. Now the voltage regulators on both of these flight controllers are very beefy, so they will run the servos fine. And there are 2 places on here you can change the voltage. There's one called VX, which is along the side, which is the voltage that you supply to all the servo outputs. By default, that's 5 volts, but you can have it to 6 or 7.2 volts, and that will run at a continuous 8 amps or 10 amps max. So that should be more than enough for the vast majority of craft that you're going to put together. And there's also a little setting for something called VSW, which is for the second camera, and that can be set at 5, 9 or 12 volts. I've set mine at 9 volts, so the 9 volt output is the same as the 9 volts for the primary camera and also for the video transmitter, just like we did in the F405. The only other thing that's worth mentioning is the amperage that's supported through the board now is 132 amps versus the 104 amps of the F405. So if you want the additional UARTs, if you want the extra camera support, the ability to flick between two cameras in flight, or you have a really beefy setup where you have two big motors where you're going to need to supply more than 104 amps, then this is probably going to be the one for you. So let me jump into iNav, and the setup is exactly the same as last time. There's no difference here in how it's all going to be put together. Now, first of all, we will flash it. So now the board's all set, let's plug it in and we will flash it with iNav for the first time. Now, we are going to use the same process as we used last time. We can just use the CLI command version to find out which target we need. Now, the fact it's jumped straight into CLI means that it isn't a compatible version of the firmware. So this is running 2.3 of iNav. I'm using the latest configurator. The latest configurator won't talk to that, but I can see the target that I need. So that's the one that we're going to need to flash to 2.4. There is another way that you can actually find this out. Let me just find Maytech F, there it is, that's the one we're going to need to flash. And we'll go for the latest version 2.4. Now, if for some reason I couldn't get that to work, then I could just jump into the Maytech manual. The Maytech manual is fantastic and actually shows you the target in iNav that you need to choose. And it's worthwhile checking in there because also along with that, it also has all the connection diagram that I'm going to use in a second once it's all flashed to connect all the pieces. So back into iNav, back in the firmware flasher. Let's scroll down to the very bottom. You've got all the release notes here of all the things it can and can't do. And then we're going to click on load the firmware online. And then we're going to click go. Now, again, this one has appeared in the top right hand corner and it says DFU. That's in bootloader mode and it is flashing beautifully. If it doesn't do this on yours, exactly as I said before, check out the Zadig link below. You'll need to fix a driver. Sometimes this, if you do this once after a Windows update, you might have to come and do it again. It's just one of those wonderful things with Windows. But there we go, programming successful. That was really, really quick. I wonder if that's something to do with the F7 processor. So now it's booting. See all the little flashing lights on it. Then once it's booted, let's click connect and have a quick look. First question is, what is it going to be installed in? We say airplane, it's going to reboot again. And again, I'm going to go through exactly the same steps. So I'm going to speed through this a little bit as I did with the F405. So as I move it around, we can see that it's moving in the display. That looks really good. We're going to go into the calibrate option and we're going to go through exactly the same steps as we did before, putting it in each 6 positions, clicking calibrate accelerometer after each of them. Once that is all done, and again, just working my way down the left hand side, it's defaulted, interestingly. Oh, looks like a little bit of a bug maybe here in iNav, but we need airplane and we need a flying wing. So we're going to click load and apply, and that will probably reboot it again. Yeah, there we go. When I said airplane at the beginning, it should have defaulted to that, so that might be something that may be fixed in a later version of iNav, no doubt. Outputs, everything's disabled, which is good. Ports, loads and loads of ports. We'll come back into this and configure it once I've plugged everything in. We'll do it slightly other way around than the F405, and then you've got configuration tab where we're going to set everything up. However, I've missed one, haven't I? Presets. Let me jump to the bottom because the right. There we go. The mini track is one of them, so we'll click on that. We'll reboot again. Lots and lots of rebooting for this stuff. And the only other thing I'm spotting here, if we go into configuration, you can see in the top there's an airspeed sensor. I'm not going to install one of those, even though we've got room for it. So I'm going to turn that off, say there's no airspeed sensor on here, and click OK. And there we go. That is the basic configuration done. Let's plug everything into this and then we'll come back in and finish setting up the ports. So with it unplugged from the computer, disconnected from iNav, it's time for us to start plugging everything in. Now the layout and how you plug everything in again is beautifully described in product pages for both ArduPilot and iNav. So S-bus input needs to go here on these 3 pins. The compass needs to go on the pins by the side, so there's the ground and voltage that's going to power it, and then make sure that you're connecting the transmit pin of the GPS to the receive pin of the UART and vice versa, and that is going to be that. Don't worry, again, I'm going to do some close-ups in a minute of how this is all plugged in, but it's just to show you physically what the connections look like that the Maytech manual is talking about. Next one then is the camera. Now this is the default camera. I do like the way that the power outputs on the 765 is a more conventional way round with the power in the middle. So you could use a standard kind of 3 pin servo connector and plug it in, and you don't have to do any rewiring. And that's into C1 or camera 1. And then the last one is going to be the video transmitter, which is going to go into the video transmitter slots just beside it, and the pin for controlling it, either with smart audio or whatever, is going to go by the side. Now here are some close-up shots of how that is all gone in, and all of the other pins along the side are going to be used for ESCs or servos. Now the ports in iNav match up with how the ports are actually written on here. So let's go back into iNav and finish setting this board up. So I've cheated a little bit. I've written down the different UARTs for what everything's connected in, just looking at the numbers on the top, so I can set this up nice and quickly. So back into iNav. I haven't got main power supplied, but we can just do the final configuration before we do that. So we need to go in the ports tab. I need to set up UART2 as GPS, and I also need to set up UART, bottom UART, as the TBS smart audio. There it is. Okay, that should do it. Let me just make sure I can get to the save and reboot button. It'll reboot again. That should be the port set up. And then if I go into the receiver and move the stick on the radio, there we go. SBus is all working. Mapping's wrong, but that's fine. Let's change it to the one that matches my radio. Click save. Try it again as I move the throttle. The throttle should move. Again, make sure your middle channel values are all 1500 for roll, pitch and yaw. Now that is done, we can carry on. So let's unplug it and we'll actually apply power for the first time. Now I'd recommend, I've already done it off screen, but just again, put the ohm meter on the power connection, make sure you haven't got any dead shorts. And here it is booting. Tells me there's an invalid font. And I haven't got a display. That's probably because the lens cap's on. It's probably going to help. Wait for the camera to finish booting. There we go. All right. Okay, so a couple of things we definitely need to do here. I can't see anything about waiting for GPS, and the font needs fixing too. So let's go back into iNav. Let me plug this back into the computer. Back into iNav, click on connect. And yeah, no, GPS at the top. Okay. Oh, I know. I missed it in configuration, didn't I? So, although the port's set up, I haven't told it to use GPS. I'm going to turn GPS on, set the ground assistance type to auto detect, click save and reboot. The GPS is powered. The port is selected that the GPS is connected to. So now when it reboots, we should see that it is. Come on. There we go. Blue GPS, rocking and rolling. Very, very happy. So if I go down to the on-screen display, let's fix the font next. Go into Font Manager. I'll just use the default one. Click on Upload the font. That's going to be uploading. While it's doing the uploading, you'll notice that the screen, the OSD will disappear because the font table is being read or written to even. When that's finished and it reboots with the new font, here we go. Looks absolutely beautiful. Fab. Okay, so next job then is to sort out that second camera. So the very last thing that we need to do is to sort out this second camera. So let me just plug this in. I'm going to plug in this second camera. This is an FXT camera. Again, it will support the 9 volts that I've set up for the output for this particular camera. So here's a close-up so you can see how that's all configured. So now with the 2 cameras installed, we have to go into iNav and do a couple of things. But actually, there is one extra little thing that's listed on the Maytech manual that we also need to do to change the accelerometer to being used too. So Let's plug that back in. Go back onto the computer, and here at the bottom of the page are the couple of things we need to take care of. We need to check and swap the gyros in iNav. Now this isn't very clear, in my humble opinion, how Maytech have actually written this out, but you're just going to follow along with each of the commands to change them over. So I'm going to have to go into the CLI. Let me get so you can see the CLI. There it is. And I'm going to have to type get gyro to use. There we go. And then we need to make sure that it is the other one, because at the moment it's 0. So it needs to be set to 1. So I'm just going to copy and paste that in, changing that default to 1, and hit enter. That's going to change that over. And there's one other thing we need to do as well, which is we need to select this. So I need to cut and paste. Unfortunately, it's an image. It would have been so handy to have that as text that you could just cut and paste. So I'll just type it in, hit enter, and then type in save, hit enter, and that'll reboot, and that'll be those last two pieces done. Again, always check the manuals for things like this. Maytech are very good at making sure you're aware of what needs to be tweaked. Maybe in the future targets that'll be done automatically, but it's worthwhile to check. So next job, now that's all done, is then to set up the camera stuff. Now I need to figure out which of the two switches on the radio I'm going to use for this. I'm going to go in the receiver tab and flick the two switches that I'm interested in. So it's channel 6 and channel 7 we'll use. You could just set it up for whichever ones you wanted. I'm going to scroll all the way down and find user 1 and user 2. There we go. Now these are defined as the two that do it. Now user 1 is the one to turn the function on and off. It appears to enable the camera switching. So we're going to have to set that as per the manual. So we need to set it with a selection at the bottom. So when it's active, it's turned off, and when it's not active, it's turned on. Which seems like a really odd way around to do it, but we'll just do it as the manual says. So kind of like that. Click on save. So when the switch is, when this mode isn't selected, camera switching is turned on. Okay. And then the next one is when we actually switch from the different cameras. So user 2 needs to be set up like that. So again, we're going to add a range, select the channel for that, slide the range to select that upper value, click save, and then as I flick those two switches, I can turn those two modes on and off. Okay. Now again, I'm going to have to power everything for this. So here we are on the bench, all the power's connected, we're fired up, the two cameras are connected, and we have the screen turned on. Can't see it very well. I'll bring it up so you can see it better. You see we've got some GPS lock, we've got 6 of them. As I flick the switch, it goes onto a black screen, but that's because I need the other switch to enable it turned on. And if I have that switch turned on and the other one, then I can switch between the regular camera and I can switch between the FXT. So just be aware of that. That's kind of how you set it up. Relatively easy to do and fun to play with. So now I have all that set, then the last two things to talk about are two optional things that you might want to do. The first of which is going to be how to configure Crossfire with these Maytech boards, and then how to configure DJI. So first of all, let's talk about Crossfire. Now for Crossfire, there are two ways that we can actually connect it up to the flight controller. The first is to enable one of the outputs on your Crossfire receiver as S-Bus. If you do that, then it's a relatively straightforward process. You just plug the S-Bus cable from that output on your Crossfire receiver that you've just configured as S-Bus into the S-Bus port on the flight controller, and surprise, surprise, it works exactly as you'd expect. S-Bus is S-Bus, so that's relatively straightforward. But you can also use CRSF, and what you need to do there is go into the Crossfire Lua script on your radio and then select not the output for S-Bus, but select two of the outputs for CRSF receive and CRSF transmit. And then you need to find a spare UART. I'm going to use UART 6 on this F405, and then plug them in with the cables. Now I'm doing it this way so that the receiver is powered, and CRSF transmit on the receiver goes to CRSF receive, or the receive pin on the UART, and vice versa. And then we've got to go into iNav itself. We need to select the port to say that it's going to be serial port, and I've moved it now from what UART 3 is default to UART 6 because we've plugged it into TX and RS6 on the flight controller, and the UARTs and the ports have the same numbering scheme, which is handy. And then we need to go into the settings and change the serial receiver type to be TBS Crossfire. And if we do that and go into the receiver, then that works as well. But with CRSF, we're also getting telemetry and other information back to the radio too over that link. So that's how Crossfire is used with these. It's really simple and straightforward. So the last one to look at then is how you would wire up or connect the DJI HD FPV system into these flight controllers too. So the first thing we need to think about is the fact that this isn't going to get the on-screen display from the flight controller. The cable that comes out the back has a number of pins that's both for power and ground, for the telemetry information, and for the ground and the signal for the S-Bus or fast S-Bus that we can select in the DJI system. So the way I've got this connected is I've soldered the plus and minus, the red and black wires, onto an ESC output, put the brown and yellow wire here into the S-Bus in, because S-Bus is S-Bus, we've already established that in this video, and also the other two cables then, the white and grey ones, are going into UART 6, and that's going to be used to send the telemetry information back to the DJI goggles so they can create the on-screen display. So I just need to plug this in, and that's all the connections made. So first job I need to do is to power on the DJI radio, press the button once, press and hold it again, and it will power up. There'll be a little red light at the bottom showing it's not connected. And then we just need to plug in the power because the DJI Air unit is going to need battery power to work. And then hopefully when that's booted, we should see the green light. There it is on the radio to show that it's all bound. So let's plug this into the computer and I'll show you how it's all working. So once it's booted, there we go. Let's click on connect in iNav. And in the ports tab, let me show you very quickly, on UART 6, I've got this DJI stuff set up, but that's for the telemetry. In terms of the receiver, as I move things around, the receiver's working absolutely as you would expect, but that's because the DJI Air unit is sending S-Bus out, it's connected into the S-Bus input, and it's all working. Now we could also select fast S-Bus, which is a faster version of S-Bus that the DJI unit can support, and iNav can too, but I'm happy with good old S-Bus. Last one then is here, is this particular piece. To get the telemetry working, we're going to have to set this to DJI FPV VTX, and that will send out, at the moment, Betaflight compatible telemetry down to the Air unit, back to the goggles, and the goggles will then use that to populate the display with voltage and all that goodness. Now this is changing, so keep your eyes on this. I would always recommend updating the firmware to the latest and greatest version with your DJI stuff and keeping up to date with the iNav developments. But if I put the goggles up to the screen here, hopefully you'll be able to see that the voltage and everything else is displayed in there, and that's because the telemetry is coming back via UART 6 into the goggles and then being shown as an on-screen display. Wow, you're still here. That was a long one, wasn't it? So we've covered an awful lot of ground. That's 2 flight controllers, 2 different types of radio, and 2 different types of FPV equipment as well. So the next video then, I guess, is for me to decide what I want to put in here and to put it in. Now the nice thing about the mini DRAC is that we've got room in here for ESC and the Maytech flight controller, and then we have these little cages each side, little depressions. GPS would fit in beautifully in one, and maybe the VTX in another, or if it's going to be the digital system from DJI, probably have to be down here with the camera at the front, and that would separate the antennas an awful lot from the GPS. Need to have a think about that. So join me in the next video. Thank you for sticking with this one, and we will actually start putting things inside this bad boy. Thank you for watching my video and watching right to the very end. If you want to find out what I'm currently working on, you can follow me on social media by searching for Painless360 in the usual places. If you'd like to become part of the inner circle, then you can become a Patreon. Details are in the description and you get lots of additional benefits. Check out the playlist section on the channel too. I organise all of my videos into playlists and it's called something like Introduction to or for Beginners. All of the content is aimed so that you can start at the very beginning and it teaches you that subject, starting with simple principles and moving up to teach you everything you need to know.